This video has review for your first quiz. My advice to you, now that you've learned all of the material that we're going to cover in this video, is to pause it and try the problems yourself before even watching me talk through them. See what you can do, and that will help you gauge how prepared you are for your quiz. And then listen to me talk through it and make sure you have those big picture concepts. So pause, give it a try, see how far you can get. First question, we've got a graph. Let's analyze the graph a little bit. Along my x-axis, I have time in seconds. And then going up the y-axis, I have something that represents distance in meters. So do notice each line here, we labeled just the 2, 4, 6, and 8, but each line represents 1 meter. And some initial observations that I'm making right when I look at this, the distance is decreasing because it's dropping over time. So first question we're asked is the initial distance. So our initial distance, remember, we look at time 0, so the 0th term at time 0, or right on the y-axis is where you can always look for that. So when I look, I'm looking at where I just made that green point right there. The initial distance is up at 9 is what that number would be. So 9 meters is my initial distance. And the reason that I know it's 9, I did just double check. This is 2, 4, 6. This line was 8, so the next one is 9. Next, we look at rate of change. And so I told you guys I like to find the next nice point is what I call it. So when I'm talking nice points, the ones that match up nicely on the grid lines. And what I can see is that I drop 1 meter for every 2 seconds. And that pattern continues. I drop down 1 meter every 2 seconds. So the way we write that up as rate of change is we can say -1 for down 1, that's why it's negative, over 2 meters per second. Another way to think about that when we think about it with proportions is that each second we're dropping half a meter. So 2 different ways to think about that. We want to write an equation. So in our equation, it's going to look like y equals the rate of change. So this one was -1/2. And rate of change is going to go next to your x plus your initial value, which in this case was a +9, so +9. And then we're asked to use the equation. So what will the distance be at 12 seconds? So 12 seconds is something that would be graphed along the x-axis because that's where I see seconds. So that's going to be substituted in for x in my equation. So I'm going to say y equals -1/2. I'm going to replace the x with a 12 plus 9. So then y equals -1/2 times 12 is -6 plus 9. -6 plus 9 is +3. So at 12 seconds, the distance will be 3 meters. Last question about this one. It says, when will this person reach their destination? So when they reach their destination, their distance would be 0 because that's where they started far away, they're trying to get somewhere. So the distance from their desired destination, once they're there, they're right there, so there is no distance between them and the desired destination. So distance is a y value. So in my original equation, I'm going to replace the y with that value of 0. And now we need to isolate the variables, so solve this one for x, which means on both sides I'm going to subtract 9, and I get -9 equals -1/2 x. Now to get x totally by itself, I'm going to divide by -1/2. And fun little math fact for you, dividing by 1/2 is the same as multiplying by 2 actually. So this is going to end up giving me a +18 equals x, which means at 18 seconds, this person will be at distance 0, so they'll have reached their destination. All right, so now reviewing the kind of linear equations in context, so interpreting them. In this example, pause to write down the important parts. Says Jackson is a plumber. He earns $50 plus $12.50 per hour for service calls. So 2 different pieces. We talked about how the amount that he earns, no matter what, is his initial value. He's going to earn that $50 steady, $50 all the time. The part that depends on something else is the $12.50. He earns $12.50 for each hour. And so that depends on how many hours he works. The $50 is steady, but the $12.50 depends on the hours. And we said that word per is one of our signal words to tell us that we're looking at rate of change. So in writing this equation, we would write y equals 1250x, and that's because that depends on how much money he's going to get, or depends, the amount of money he gets from that piece depends on how many hours he works, but then he always gets the $50, so plus 50. Next question says, how much money does Jackson earn on a service call that lasts 6 hours? So we said, we probably should have defined our variables up here. In my equation, I was letting x represent the number of hours, and y is representing the money that he earns. So money earned or income. So amount of time is an x value in my equation. So in my equation, I'm going to replace that x with a 6 and then solve for y. So this one, the y is already by itself. We're just number crunching. Use a calculator if you need to. So 1250 times 6 is $75. So from the amount of hours he works, he's getting $75, but he also gets that $50 fee. And this is actually a pretty common real world scenario. A lot of times if you have someone come work at your house like a plumber or an electrician, they charge a steady rate and then it adds on a little bit for every hour that they work. 75 plus 50 is 125. So he is going to earn $125. Last question, how many hours does Jackson work if he charges a total of $250? So the money earned, if he's making $250, that's a y value. So in my equation, I'm going to replace the y with 250. So 250 equals 12.50x plus $50. And in solving this, we're trying to get x by itself, so we remove the addition, the plus 50, by subtracting 50 on both sides. And that's going to give us, I'm going to move over here, that's going to give us 200 equals 1250x. And now in getting x by itself, we need to divide by 1250 on both sides. And 200 divided by 1250 is 16. So that tells me that he works 16 hours if he was able to charge $250. So study for your quiz. Use these examples. Go rewatch old videos if you want. Do some extra practice problems from things we've done in class or your Delta math. But do whatever you need to get ready for your quiz.